Have you ever looked up at the night sky, really looked? Past the city lights, past the clouds into that deep, dark, velvet expanse. It's filled with countless stars. Each one a sun, many with their own planets. Our own world is just a tiny speck of dust circling an average star in an ordinary galaxy. Yet from this humble outpost we dare to ask the biggest questions. What are the rules that govern this cosmic dance? How did it all begin? Where is it all going? This is the grand and noble quest of physics. It's a story about us. It's a story about everything. It's the greatest adventure of the human mind. The universe isn't just out there. It's in you. The iron in your blood, the calcium in your bones. These elements were forged in the heart of a dying star billions of years ago. We are, quite literally, stardust. Physics is the language that tells this incredible story, an instruction manual for the cosmos, revealing connections between the largest galaxies and the smallest particles, written in mathematics and observation. Think about the device you might be using to read this. A phone, a tablet, a computer. These are not just gadgets, they are triumphs of physics. Miniature cathedrals built on our understanding of electricity, magnetism, and the strange rules of the quantum world. Transistors power its brain, billions of them. We mastered the behavior of electrons. The GPS that tells you where you are works because we understand Einstein's theories of relativity. Time literally ticks at a different rate in orbit than it does on the ground. Without physics, your phone would just be a rock. Physics extends far beyond your pocket. It's in the hospitals that save our lives. MRI machines use powerful magnets and radio waves. Lasers for delicate surgeries come from our understanding of light and atoms. The energy that powers our homes comes from nuclear reactors splitting atoms and solar panels capturing photons. We live in a world built by physics, a symphony of cosmic laws. Every time you cook, you apply thermodynamics. When you play a sport, you intuitively calculate trajectories, forces, momentum, Newton's legacy. Physics isn't just classroom theory, it's the invisible architecture of daily life. It describes the flight of a ball, the warmth of the sun, the sound of music, and the rhythm of our heartbeat. When we talk about the future of physics, we're talking about the future of humanity. Just a few years ago, we gained a new sense, a new way to perceive the universe. For centuries, we looked at light, visible light our eyes see, the invisible radio waves, X-rays. But in 2015, something changed. For the first time, we felt a tremor in the fabric of spacetime itself. We detected gravitational waves, ripples in the geometry of the universe, created by the collision of two massive black holes, a billion light-years away. It rocked science and opened a brand new window onto the cosmos. Imagine a silent movie that was astronomy before. We could see the drama but not hear the soundtrack. Now we can. These waves are the sound of the universe. They carry information that light cannot. Probing supernova interiors and witnessing neutron stars merge, events shrouded in dust and chaos. It wasn't just Einstein confirmed, it was the birth of a new field. We are now cosmic seismologists, listening to creation and destruction. Another marvel. In 2019, the Event Horizon Telescope captured a black hole's shadow by linking telescopes across the globe into a planet-sized lens. The abyss stared back, exactly as physics predicted. These breakthroughs change our perspective and fuel ambition. If we can hear black holes collide and photograph the edge of infinity, what other secrets await? What other mysteries are we now equipped to solve? The journey is just beginning. As much as we've learned, we are surrounded by a profound mystery. A cosmic ghost. Galaxies spin so fast they should fly apart. The gravity of visible matter isn't enough. It's as if an invisible hand provides the extra gravitational grip. We call it dark matter. It doesn't shine, reflect, or interact directly, except through gravity. All stars, planets, galaxies, life, only about 5% of the universe. About 27% is dark matter, and 68% is dark energy pushing space apart. 95% is unknown. We are strangers in our own cosmic home. Finding dark matter's nature is one of physics' biggest quests. Is it a new particle passing through us by the billions? Deep underground, shielded detectors hope to catch even one bump. One definitive detection would be a revolution. It would unveil a shadow world shaping the cosmos, like turning on the lights in a dark room. It would rewrite textbooks, explain galaxy formation, and point to more complete theories. The ghost is there. We feel its presence. Now we must find a way to see it. Now let's shrink down, way down, smaller than an atom, to the realm of quantum mechanics. Down here the world is bizarre. Particles can be in multiple places at once. They can be connected over vast distances, spooky action at a distance. Once a curiosity, now we're on the verge of harnessing it. We're learning to build quantum computers. Unlike classical bits that are on or off, qubits think in possibilities. A classical bit is a switch 1 or 0. A qubit is like a dimmer, on, off, or some combination superposition. With entanglement, many possibilities are explored at once. For certain problems, quantum computers could be exponentially more powerful. It's a fundamentally new way to process information. Imagine designing materials atom by atom room temperature superconductors, perfectly efficient power grids, simulating chemistry for new medicines and catalysts, breaking current codes and creating perfectly secure communication. Qubits are fragile vibrations, heat, or stray noise destroy their state. Engineers are shielding and controlling them, but we're early like the vacuum tube era. Progress is fast. By 2050, large-scale quantum computers may tackle world-changing problems. We're learning the universe's native language. Is our universe the only one? Once philosophy or science fiction, now a serious testable idea. Some of our best theories, string theory and cosmic inflation, don't just allow other universes, they almost demand them. Our universe could be one bubble in a vast sea of bubbles, the multiverse, each with its own laws. Physicists search for evidence. A collision long ago might leave a cosmic bruise in the microwave afterglow of the Big Bang, a strange cold or hot spot. Such a signal would be profound, changing our place in the cosmos. If other universes exist, stars, planets, life might be outcomes of a cosmic lottery. It's the controversial anthropic principle. Evidence would dwarf Copernicus's revolution, reshaping philosophy, religion, and our sense of self. We're knocking now. By 2050, more powerful telescopes and better theory might offer a glimpse beyond. What happens if we solve these mysteries? What would life be like if we understand dark matter, harness quantum computing, and confirm other universes? Practical applications could be astonishing. A theory of everything could change everything, unlocking new energy sources, clean, safe, virtually limitless. Imagine a world without energy scarcity, power as abundant as air. This could help solve poverty and climate change. Understanding dark matter could revolutionize gravity. Could we one day manipulate space-time, build warp drives? A century ago, the moon sounded impossible. New physics opens doors and expands the achievable, perhaps enabling true star exploration. Quantum computing will create industries and jobs and big challenges. Cybersecurity must be reinvented. A multiverse discovery would spark a global conversation about purpose and place, changing culture. This future isn't guaranteed. It must be built, with investment in basic research, patience, and a society that values curiosity. From lab to home can take decades. Support the quest and we plant seeds for a world we can only begin to imagine. Is there an end to physics? Some dream of a final theory, a single equation unifying quantum mechanics, the physics of the small, with general relativity, the physics of the large, explaining constants and particles? Would science be over? Not at all. A final theory is like having the chess rulebook. It doesn't mean you've played all games or grasped all strategies. The universe is far more complex. Even with the rules, working out consequences from galaxies to consciousness would take millennia. A final theory would be a beginning, the ultimate toolkit, to create new forms of matter, manipulate space-time, maybe even craft tiny universes. It unlocks infinite new questions, or perhaps there is no final theory, only deeper layers forever. That's even more exciting. The quest never ends. New mysteries to solve, new frontiers to explore, new wonders to discover. Our descendants will still look up and ask, what's out there? The universe is under no obligation to make sense to us, and yet it does. Its laws can be written in mathematics and discovered by curious apes on a small rocky planet. Our ability to comprehend the cosmos is a gift, the core of what makes us human. We are driven by insatiable curiosity. This quest is our birthright. It is written in our DNA. Discoveries will change our world. As Maxwell and Faraday once did, physics gives us perspective, the cosmic perspective. We are all connected, all made of stardust, sharing one tiny planet. Against the universe's grandeur, our squabbles are small. Physics is hopeful, showing what we achieve together, guided by evidence, unafraid to dream big. Problems that seem impossible today may be solvable tomorrow. The story has no end. So keep looking up, keep asking questions, nurture curiosity. The future of physics lives in everyone who has ever wondered about the stars. The universe is waiting, its secrets scattered among galaxies, hidden in atoms, woven into space and time. Our quest is to find them. The adventure is just getting started.